Today, we'll be looking at how extraterrestrial life could be hiding in our galaxy's interior ocean worlds. If you're new to this channel, welcome. This is Mr. Singularity, where we explore the scientific and technological breakthroughs shaping the future as we know it. Liquid water is essential in the hunt for alien life. Water is essential for life as we know it. This discovery has prompted scientists to search for siblings of our planet orbiting other stars as part of humanity's continuing search for companionship throughout the cosmos. Twin Earths would be rocky planets, the size of ours, that circle their stars in the habitable zone, a temperature range in which liquid water may exist on a planet's surface, as it does here. The most recent estimate of the number of Earth-like planets in the galaxy is appropriately enormous, weighing in at a minimum of 300 million possible alien Earths, and maybe a lot more. Even still, that figure may be a significant underestimation of the number of celestial planets capable of supporting life as we know it. And we simply need to look at our own solar system to know why. The Earth's surface seas, it turns out, are the exception to the norm when it comes to liquid water. There is evidence for 7 other seas in the solar system beyond Earth, and theory suggests that there are at least 2 more. However, they are all underground seas, enclosed in the miles-thick ice and stony crust of outer solar system's moons and dwarf planets. If we discover that such interocean planets are as common around other stars as they are here, it will increase the number of opportunities for life to form throughout the galaxy, increase the chances of its surviving over time, and may even explain why we have yet to uncover persuasive evidence of other advanced civilizations out there. That's according to Alan Stern, a planetary scientist at the Southwest Research Institute, analyzes the ramifications of a galaxy full of star systems, in which worlds with seas under the surface are prevalent, similar to our own solar system. Remember that the report is an extrapolation of existing results of an examination of their consequences. Astronomers are still gathering data on ocean worlds in our solar system, and they are just beginning to look for evidence of probable exomoons circling planets in other star systems. It's also early days for determining the makeup of exoplanets, let alone their moons. That's so, given what we know, it's an intriguing perspective, and if correct, it may imply our own experience here on Earth is much more unique than we think. Water. Water everywhere. The outer solar system is teeming with water, frequently in the form of vapor or ice. However, we are startled to learn that liquid water not only occurs but is significantly more prevalent than predicted. The greatest evidence implies that underground seas exist on Jupiter's moon Europa, as well as Saturn's moons Enceladus and Titan. They may, however, be present on numerous additional outer solar system moons, including Callisto, Ganymede, and Triton, as well as the dwarf planet Pluto. Gravitational energy is in charge of moons circling gas giants. As the moons move in elliptical orbits around their planets, fluctuating gravitational pressures stretch their innards and generate huge quantities of heat, more than enough, it is thought, to sustain liquid seas. In the case of Pluto, and maybe other Kuiper Belt objects, scientists believe radioactive elements in the core maintain its seas warm and liquid. These inner ocean worlds are among the greatest areas in the solar system to seek life beyond Earth. We already know that extremophiles, single-celled animals that live in severe conditions, survive near volcanic vents deep in our own seas, where they are largely blocked off from the sun. At the very least, scientists believe that comparable life forms may establish a foothold on outer solar system moons under the correct conditions, if the rest of the galaxy looks like home. What if other star systems, full of subsurface oceans on moons and dwarf planets, are like ours? Stern indicates in his study that internal ocean worlds offer various advantages over outer ocean worlds, and that if they are frequent, it is significantly less likely that we are alone in the universe. But it may also be far more difficult to establish the case. Because the interior oceans are surrounded by kilometers-thick rocky crust, the conditions around the host star are less dependent. As we have seen in our solar system, they are able to remain living far beyond the outside of the external ocean world and around a wider range of stellar types. Stern writes that they may not even require a host star, that they could exist on wandering planets ejected from their systems. Furthermore, if life evolved into a world in the inner sea, the natural shell of this home world would protect him from a variety of existential risks confronting life on the surface of the planets. These include asteroids, comets, explosives, and dangerous stereos from the host of stars of nearby supernovae. In fact, such planets need little for strong magnetic fields, such as Earth, to protect against radiation. Such conditions could be ideal for the development and prosperity of life. And this could mean that life happens more often and lasts longer on the inner worlds of the ocean than on planets with superficial oceans. But if there is life in these worlds, both are big ifs, Stern emphasizes, more particularly intelligent life, it will be harder to discover. The same ice and rock projective layer that creates life-sturdy environments also secure life from being easy to detect, said Stern. Scientists, for example, aim to test the biosignatures of exoplanets in the near future. These life signs are contained firmly in the shells of the inland ocean worlds. And while Earth leaking out radio signals from our civilization like a sieve, the thick, icy, and rocky coats of the inland ocean worlds would not be escaped. In fact, Stern speculates that the smart life evolves on these worlds would not be as conscious of the larger universe, communicate with electricity and space travel. Finding proof here first. All of this, of course, is dependent on how common interior ocean worlds are and if they are capable of supporting life. We'll probably learn more about both in the coming years. There are already orbital surveys of Jupiter's moon surfaces in the works. Scientists intend to send landers to these moons in the future to sample the waters directly. Although finding exomoons remains difficult, more sensitive instruments and innovative new methods may give information into how frequently they occur and what they are compromised of in the future. In the meantime, it's fascinating to hypothesize how life might evolve in surroundings so different from our own. Asteroid and comet impacts, for example, have had a significant impact on the evolutionary roots of life on our planet. And for humans, the motions of the sun, moon, planets, and stars have inspired mythology, physics, the idea of gravity, and a better understanding of our place in the cosmos. What if this window into the cosmos was closed to us? What stories would we tell then? Do you think there's extraterrestrial life hiding in our galaxy? Let me know down in the comments below, and check out one of these other videos. This has been Mr. Singularity, and I'll see you on the next one.